so your first quiz, your take-home quiz is due today. Just put it in your folder, and I'll take it out of there and grade it for Friday, hopefully. Today we're going to talk about the product and quotient rules. So we got a little intro to the quotient rule as we were working on the projects last class. So hopefully, that'll help us today. And we're also going to do some review of kind of pre-calc college algebra stuff, power, polynomial, and rational functions. Okay, so today we're going to learn 2 more derivative formulas, the product and quotient rules, and do a little review. So remember that d dx of some stuff in brackets means the derivative of what's in the brackets. So we're now going to expand our collection of derivative rules to include products and quotients of functions. Unfortunately, derivatives of products and quotients aren't as nice as derivatives of sums and differences. So when you want to take a derivative of a sum or a difference, you can just take the derivative of each term separately. But it doesn't work like that for quotients and products. So if it were really nice, d dx of 3x plus 2 over negative 2x minus 1 would be 3 over negative 2, right? You just take the derivative of the top and the derivative of the bottom, but that's not how you take derivatives of quotients. So here are my rules. The derivative of a product, d dx of f times g, is not f times g prime. And the derivative of f over g is not f prime over g prime. They're just not true. No, no, no. No, no. So here's the real product rule. The derivative of f times g is f times the derivative of g plus g times the derivative of f. I like to think of it as first and second, right? So the first times the derivative of the second plus the second times the derivative of the first. So this is how I remember it, like in English words instead of symbols. So f is your first function, g is your second function, so it's first times the derivative of the second plus the second times the derivative of the first. All right, so we'll do an example. I want to find the derivative of a product, 7x to the 4th plus 2x cubed minus 5x minus 1 times 4x squared minus 3x plus 8. So I could distribute this all out. I could multiply this all together and then just use the power rule over and over. But we're going to save a lot of work by using the product rule. So this guy is like my f. This guy is my g. They're being multiplied together. So it's f g prime plus g f prime. Okay, so my derivative is f, 7x to the 4th plus 2x cubed minus 5x minus 1. F times the derivative of g. The derivative of 4x squared minus 3x plus 8 is 8x minus 3. That's right. Everybody said it correctly. Wow. Plus, so that's f times g prime plus g, which is 4x squared minus 3x plus 8, times the derivative of f. And I'm going to need a little more room than that. The derivative of f would be 28x cubed plus 6x squared minus 5. Good. So there's my derivative.
So first part is just that.
Yep.
Part is
Yep. F g prime g f prime. And generally, for all of the course, unless something specifically tells you to simplify your result, don't, right? You're highly likely that you might make a mistake in your arithmetic. Just leave it. Unless the next thing that you were supposed to do is set that equal to 0 and solve it, then you're probably going to have to do some arithmetic to solve. No, because this is the product rule. Yep, and the product rule is just this guy.
Okay.
Simpler than the quotient rule.
Okay.
Simpler looking, yeah. So the quotient rule, the derivative of f over g, what's the matter? Yeah, I just ran out of room, so I wrote it underneath. That's a multiplication, yep. Okay, so my quotient rule, the derivative of f over g is g times f prime minus f times g prime all over g squared. And I like to think of this, again, as numerator and denominator, or bottom and top. And I find it easier to remember like an English words version than the symbols. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Okay, so let's find the derivative of this quotient. This is the one we tried to do at the beginning, and we said if life were easy, the answer would be 3 over negative 2, but it's not. So we're going to call this f and this g, the top and the bottom. And so my derivative is going to be the denominator times the derivative of the numerator, which is 3, minus the numerator times the derivative of the denominator all over the denominator squared. So my general rule of thumb for when to simplify and when not to simplify is if you can make a big difference in your simplification in like 2 steps or less, go ahead and do it. But if it's going to take you a page of work to simplify something, just don't bother, right? So in this case, I would say go ahead and simplify it. All you got to do is distribute and combine like terms, and it's going to look much better. Okay, so 3 times negative 2x is negative 6x. And then I'm going to have plus 6x, so 12x. And then negative 3 plus 4 is plus 1 over negative 2x minus 1 squared. Oh, that's wrong. Sorry. It's negative 6x plus 6x, so there's no x's left. That's exactly what it means, yeah. So it said first find the derivative, right? So we did that. That's the derivative. And then we want to use it to find the derivative, and this means evaluated when x equals 4, right? So now I'm going to just replace the x with a 4. So write it out with good notation. D dx of 3x plus 2 over negative 2x minus 1 when x equals 4 is, you just take your, that means take the derivative and plug in 4. So if I put a 4 in here, I'm going to have 1 over negative 2 times 4 is negative 8, minus 1 is negative 9, squared is 81. So let's see what I label this. This is g f prime. That means take the derivative, then plug in x equals 4. Yeah. Questions? I plugged 4 into the derivative that I just calculated. Yeah, so this is plug in x equals 4. All right, so that's it. You're going to have some practice in the group activities with the product and quotient rules. You'll have some practice with optimization. And you're also going to do some self-review of power, polynomial, and rational functions.